Ospf neighbor states. The Ospf speaking router has to transition to multiple phases before it becomes fully adjacent with its neighbors. The following list below shows the states of transitions in the Ospf, starting with the down state to the final stage of the full state. The Ospf starts with down state, then followed by init state, then followed by two-way state, then followed by X-start state, then followed by exchange state, then followed by loading state, and finally goes to full state. Let's have a look at each one of these states in detail. In down state, no neighbors are detected. This means no hellos are heard from the neighbor. If the Ospf neighbor is in the process of going down, then it will clear its link states, which include database summary, link state requests, and any retransmissions. In init state, the hello packets are seen from the neighbor, but there is no bidirectional communication established. In two-way state, the router has seen its own router ID from its neighbor hello, meaning bidirectional communication is established. In X-start state, the routers will decide who will be master and who will be the slave. The router with the highest router ID becomes the master wins. It will also determine the initial sequence number for the DDP packets. DDP stands for database description packets. In exchange state, the router will send the database description packets to its neighbor. It will be a summary of the entire link state database. It will also use LSR to request the LSA. LSR stands for link state request and LSA stands for link state advertisement. In loading state, the router will use LSR to request the most recent LSA, which is missed in the exchange state. LSR is like a request, and replies to that request are LSU. LSU stands for link state update. In full state, the neighbors will be fully adjacent to each other, which is the happy state in Ospf.